Hi Pre-Algebra. Today we're going to be learning about the Pythagorean Theorem, and the Pythagorean Theorem works for right triangles only. So that's super important, only right triangles, and it's for side lengths of right triangles. It has nothing to do with the angle of a triangle, but it has to do with the side lengths of a right triangle. And a new word we have here is hypotenuse, and the hypotenuse is the longest side of a right triangle. It's always directly across from the right angle, which we'll get to in a minute. And when using the Pythagorean theorem, the hypotenuse is always C in the formula. Always, always, always C is the hypotenuse. So this first part here has us just circling the hypotenuse in the following right triangles. So if you know that this is a right triangle, I just said that the hypotenuse is the longest side. Well, the biggest number here is 13, so the hypotenuse has to be 13. So the largest number of a right triangle. Here, it's missing a side length, but I know that this is the hypotenuse because it's directly across from that right angle. Directly across, that's always the hypotenuse. And then the last example here shows a rectangle, which might be a bit confusing. However, we can use the Pythagorean theorem to find the diagonal of a rectangle. So when we cut this in half diagonally, now I have two right triangles and I have their side lengths. The diagonal is always going to be the hypotenuse. And notice how it's directly across from these right angles. And the reason why the Pythagorean theorem works, first of all, the Pythagorean theorem, I'm going to say it, and I wrote it a bunch in purple today, so hopefully you remember it. A squared plus b squared equals c squared. You will use it all the time next year and in geometry as well. So a squared plus b squared equals c squared. These a's and b's, the a and the b I did in the same color because they're interchangeable. They both just mean a leg of the right triangle, whereas c has to be the hypotenuse, so I did it in a different color for you. So a leg squared plus a leg squared equals the hypotenuse squared. And this is kind of just a visual for you to see why this works. If I have a triangle, the triangle in the middle here, and I have squares coming off the outside of it. So I have a triangle that's 4, a leg is 4, a leg is 3, and I have that hypotenuse of 5. And I have these squares broken off of it because 4 squared is 16, and 3 squared is 9. So there's 9 squares within this one, 16 squares within this one, that's 4 by 4. And then the hypotenuse here is tilted off to the side, but I know that it's 5 units long because of the grid. And then when I set up my Pythagorean theorem, so a squared plus b squared equals c squared, I'm going to fill my legs into a and b. And this orange and green, that could be flipped around. It does not matter for a and b. The legs can be interchanged. Whereas 5 had to be the c because 5 is the hypotenuse. So when I plug this all in and see if it equals, well, 4 squared is 16, 3 squared is 9, and 5 squared is 25. So 16 plus 9 is 25. So that's showing me this is kind of like a very, very quick informal proof of why the Pythagorean theorem works. So next we're going to see the 3 main reasons why we would use the Pythagorean theorem. And the first one is to prove whether or not a triangle is a right triangle. The next is to find a missing side length of a right triangle, either a leg or a hypotenuse. And last but not least, we can use it to find the distance between 2 points on a coordinate grid. So we'll go through examples of all of those right now. So the first one is going to be, the question is this a right triangle? And I already wrote out the Pythagorean theorem for you. I suggest writing this out for every problem that you do until you're like really comfortable with it. Write out the formula and you can plug it in. So if I'm looking at the side lengths given to me and I want to know if this is a right triangle, first I need to identify which one is the hypotenuse. And I know that 8 is the biggest number out of those 3, so 8 has to be C. And then I have 4 and 6. It doesn't matter where I put them for A and B. I'll just do 4 squared for A, and we'll do 6 and square it for B. And then I'm just going to solve. 4 squared is 16. 6 squared is 36. And does that equal 64? That's what we're looking for. Well, 16 plus 36 equals 52. And 52 does not equal 64. Therefore, this is not a right triangle. We would say no. If I have a triangle with side lengths of 4, 8, and 6, it would not be a right triangle. Next example, I'm going to fill in right away. I know 17 is the biggest side length, so I'm going to fill that in for C, for the hypotenuse. So square 17, 8 and 15, it doesn't matter where I put them. So I'm going to do 8 squared out front, plus 15 squared, and does it equal 17 squared? That's what we're looking for. Well, 8 squared is 64, 15 squared is 225, and 17 squared is 289. Now when I add these values up here, I do get 289, so it does equal. Therefore, this is a right triangle. Now why don't you pause the video and try this one on your own, and I will do it out for you. But if you pause it, you can try it before you listen to me do it. So for this one, 41 is my biggest number. I'm going to plug that in for C. A and B don't matter where they go. So 9 squared is 81. 40 squared is 1,600. And does it equal 41 squared? Well, 41 squared is 1,681. So hopefully you can see very quickly that those added together do equal this. Therefore, yes, it is a right triangle. So that was just a quick intro for you. The next 6 that we're going to be doing are solving for a missing side length. And I would say this is the most common application of Pythagorean theorem. And I think the biggest thing here is looking for which one's a hypotenuse, first of all. So what side length are you looking for? And making sure to follow directions. So am I looking for my answer as a whole number? Am I looking for it as a simplified radical? Or am I looking for it as estimated to the nearest tenth? So I'm going to come back here and we'll do the whole number first. This is the top left one in your notes if you have them printed out. And I want to choose what side of my triangle is the hypotenuse. So I have a 6 and an 8. I don't know what this side length is. That's what I'm solving for. And I can see that this is across from the right angle. Therefore, this has to be C. That's the longest side. It's the hypotenuse. Again, it's across from the right angle. So I'm going to plug, C is going to be my variable, and I can plug 8 and 6 into A and B. And I've said it a few times, but I want to say it again because it is, some kids get confused with this. A and B don't matter. You can switch them up. You could put 6 here and 8 here, or 8 here and 6 here. It does not matter. So I'll put 6 in there. We'll put 8 in there, remembering to square them. And I'm going to solve for C. Now notice my variable is C squared as of right now, so I'll need to deal with that in a minute. 6 squared is 36. 8 squared is 64. And I don't know what C is. That's what I'm looking for here. When I add these together, I'm left with 100. But 100 equals C squared. 100 does not equal C. 100 is not my hypotenuse. I need to do the inverse operation of something squared. So if I go back to adding and subtracting, if I have adding in an equation, I subtract to get rid of it. If I have multiplication and division, you do the opposite to get rid of something. When I have something squared, the square root is the opposite. So to undo this C squared, I'm going to do the square root. And when I do the square root of 100, I know that C is 10. So my hypotenuse I just solved for is 10. We'll move on to the next one, and if you have the notes printed out, you see that this is asking you to simplify to give your answer as a simplified radical, which is what we did earlier last week when we broke it up using a factor tree, the radical at the end. So we're still doing the same process, but we just want to be careful with how we give our answer. So for this one, I am looking for the hypotenuse again. I know that because it's this angle that I'm looking, or this side length that I'm looking for. It's across from the right angle. Therefore, I'm going to keep C as my variable. And I'm going to plug 6 and 2 into A and B. It does not matter what order they're in. So do 6 squared plus 2 squared equals c squared, and I'm going to solve. 6 squared is 36, 2 squared is 4, and that equals c squared. When I add these together, I get 40 as c squared. Now that is not my hypotenuse. I'm not done yet. I need that variable completely by itself, so I need to undo it with a square root. So I'm left with the square root of 40 here. Now sometimes you're able to just type that in your calculator and you'll get a decimal answer that you can round, but here the directions ask me to give my answer as a simplified radical. So I'm going to go ahead and make a factor tree. A simplified radical is when I make a factor tree and pull pairs out as friends. So I'm going to break this down into 4 and 10. I'll break the 4 into 2 and 2, and I can circle those, they're prime. And the 10 can go into 5 and 2. Circle those, they're prime. Now there's no number up here. There's never going to be with Pythagorean theorem. This is a 2. Just as a reminder from the simplifying radicals video that you guys watched earlier, I need pairs of 2. I need friends to play outside. So I have a 2 that can come outside. I have a 5 and a 2 left. They don't have a friend. They're not playing outside. They're going to stay under the radical and multiply. 5 times 2 is 10. So my answer, my hypotenuse of this triangle, given in the form that the directions are looking for, is 2 root 10. And we would be done. Same process, just a little bit of extra work at the end. And finally here I have an example rounded to the 10th place. I see that I'm still finding the hypotenuse. I know that because it's directly across from the right angle. So I'm going to go ahead and plug in the legs. I know that the legs are 5 and 3. 5 squared plus 3 squared equals c squared. I don't know the hypotenuse. That's what I'm solving for. So 25 plus 9 equals c squared. And 25 plus 9 equals 34. Now at this point, it's asking you to do a 10th. Now sometimes you will not have a calculator for this, and you guys know how to do that from the estimating radicals video last week when you had to figure out along your perfect number line, your perfect square number line, where 34 fell. So you would be looking in between 25 and 36 and do it out that way. Because we already learned that, to save time, just type it into your calculator. I know you all have calculators at home. Even if I told you to estimate it not using a calculator, you probably would anyway. So if you plug the square root of 34 into your calculator, you end up with 5.8 when rounded to the 10th place. So 5.8 would be your hypotenuse, and you would be done with that one. So those 3 we're finding when I don't know my hypotenuse, and that's purposely set up that way. The next 3 are going to be finding legs, and we'll look at why that is. So down here I have a triangle. It's asking me to round to a whole number, so it's a nice easy one. And here, if I was looking to label the parts of the triangle, I see that 20 has to be the hypotenuse because it's directly across from that right angle. So right away I'm going to fill in 20 into C. C has to be the hypotenuse. That's really important. And then A and B, they don't matter. Remember, we were able to switch them back and forth above. Same thing here. You could plug 16 in for A, or you could plug it in for B. It does not matter. So let's say 16 squared plus B squared. If you wanted to, try it at home flip-flopped, and you'll see that you get the same thing. And then I'm just going to solve. So I have 16 squared, and I know that 16 squared is going to be 256. B squared is what I'm solving for. That's my variable. And 20 squared is 400. Now this looks a little different than the ones that we've already done because my B squared is not alone. So I need to move 256 to the other side. I'm going to do that by subtracting. Those cancel. My B squared's now alone. Remember, if you do it to one side, you've got to do it to the other. We spent a lot of this year on that. And 400 minus 256 leaves me with B squared equals 144. Now I'm not done yet. That B is not alone. It's got that exponent attached to it. To undo the squared, to undo that B squared, I'm going to do the square root of 144. And I know that the square root of 144 is 12. Therefore, this side length is 12. And just a quick check, guys, too, your hypotenuse should always be your biggest number. So this works, this checks, but if you got, just for example, I'm just throwing a number out there, let's say if you solved and you ended up with 25, or if you forgot to do the square root and you got 144, that doesn't make sense. So always go back. I know you've heard me say it a million times this year. Does your answer make sense? That makes sense there because it's less than the hypotenuse, as much as it can make sense anyway. So let's do the next one. We're going to do finding another leg here. This one's asking me to do a simplified radical though. So simplified radical, same process as before. I just have that extra step at the end where I need to break it down a little bit. So for this, I'm going to look and see what I'm going to plug in where. And I see that 8 has to be my hypotenuse because it's across from that right angle. So I'm going to plug my hypotenuse in for C. 6, it doesn't matter. We'll do one where we plug it in for B, just so you can see. And we'll solve for A here. Why not? So I'm going to go through A squared. I don't know, obviously. That's my variable. 6 squared is 36. And it equals 64. 8 squared is 64. Now I need to isolate that A squared, so I'm going to subtract 36. So I'm left with A squared equals 38. Now my A is not alone. Again, I need to find, I need to do the square root of it. So this is not done. I'm going to do the square root of 38. And this is asking that because of the directions, it says simplified radical, I need to break that down. So I'm not just going to type this into the calculator or and round it to a tenth. I'm going to break it down. And let's just say this equals 2 and 19. Now those are both prime. I can't break that down anymore. I have no pairs of friends. Nobody can play outside. So my simplified radical answer here happens to be 38. They're the square root of 38, I should say. And you are done there because that can't break down anymore. And now we have one more example of when we're finding a leg. This one's asking to round to the nearest tenth. And for this one, I already told you we're finding a leg, but I know that 10 is the hypotenuse because it's across from the right angle. So I'm going to plug it in for C right away. I'm going to plug 9 in for A this time, but it doesn't matter if you do A or B. And I'll solve for B squared, that other leg. So 9 squared is 81. B squared, I don't know. 10 squared is 100. And now I need to isolate my B squared. So I'm going to subtract 81 from both sides. And I'm left with B squared equals 19. Now I'm not done yet. 19 is not my leg. And just again as a check, if I happen to stop and forget that I had to do the square root, 19 is more than my hypotenuse, so that would not make sense. I need to figure out what the square root of 19 is, and when I plug that in my calculator, I end up with 4.4. Now just to go back and talk about estimating square roots super quick, if you estimated this using the method that we did with your perfect square number line, we would be looking at a number line between 16 and 25. And your mixed number that you would come up with would be 4 3/9, which comes to 4 1/3, which is about 4.3. So if you had estimated, you get 4.3. Remember, we're not human calculators. We can only do the best that we can. This method gets us the closest that we can get there. But if you use a calculator, it's 4.4. So just as a quick reminder that an estimation is not exact, but it's as close as we can get. All right, so those were our examples of finding a missing side length or a missing hypotenuse. The last thing that we can use Pythagorean theorem for is when we want the distance between 2 points. And there's another formula for that as well, but today we're going to use Pythagorean theorem to find it if we have a coordinate grid. So this example says I have these 2 points. I want to know what is their distance in units apart from each other. Well, if I just plot them, I already plotted them for you, so 1, 3, and 4, -2. If I just go ahead and plot them and connect them, I can't count how far away they are because it's a diagonal. So we can use the Pythagorean theorem by connecting these 2 points to make that diagonal, and then kind of creating a right triangle along the grid lines of the graph. Now I know that this is a very rough sketch of a graph on my shower wall, so bear with me here. That is about it, what it would look like. If you needed a better sketch of it, I have it here on the notes that are printed out. So I can see when I count that I have a 5 by 3 triangle. It's probably easier to count up here with the grid lines. So I have a 5 by 3. Come back here. So I know that I have a side length of 5 and a side length of 3. And remember, diagonal with Pythagorean theorem tells us that's the hypotenuse. So I'm going to plug my legs in pink. 5 squared plus 3 squared, and I don't know what my hypotenuse is. My hypotenuse is going to be that diagonal. So again, I'm just solving just as normal. It's just kind of a different presentation of this. The math behind it is not different. 25 plus 9 gives me 34. And these directions actually don't tell me how to round it. So the most typical way would be to just type it in a calculator. If it's a whole number, leave it as that. If it's not a whole number, typically round it to a tenth, but make sure you look for the directions. There happen to not be any here. So we'll just say if you plugged in the square root of 34 into your calculator, we actually already did the same problem up above. The square root of 34 is going to be 5.8. So these 2 points are about 5.8 units on your graph apart. So those are the 3 uses for Pythagorean theorem. Hopefully that was helpful. And if not, you guys make sure you reach out. We can Zoom, we can talk through Remind, we can email back and forth. If the Zoom times don't work for you, please let us know. We're happy to set up a separate Zoom for just you, or maybe you and a few friends. That is totally fine, but you need to let us know that you need the help. So hopefully we'll see you guys. Your next Zoom after this video is going to be on Thursday. So that'll be tomorrow if you're watching this on Wednesday when you should be. And you guys will also have one on Friday as well. So look for those Zoom links in your email, and hopefully we will see you soon.